Okay, we're going to look at the 2021 paper. Let's have a look at question 1. And actually, just as I set this up, I go through all the questions, just have a little look. And, you know, when you go in to do your exam paper, you might want to do that just to kind of settle you down, have a wee think about, you know, what you want to do for the questions. So, you know, this one, clearly tangent. So we're thinking it's going to be a straight line type question with some differentiation. If I go over here, we're thinking, well, hopefully, again, pause these as we get to the question if you want, and you can think about it. But to me, I'm thinking it'll be reverse chain rule. You know, it's one of our composite functions. And if I go further along, question 3, we've got rate of change. So we should be thinking rate of change means differentiation. You know, so right away we've got some differentiation and integration. And the next question, obviously a straight line question, so that's not too bad. Clearly a wave function question. Integration, because we've got area under a curve. Let's go down to the next one. Sketch the graph of the differential. Okay, that's not too bad. Solving a trigonometric function. Again, looks complicated, but if you imagine that was just 2 sine x plus 1, very easy. So there's just a slight extra twist at the end there with the period and the shift. And our old favourite, this looks like an optimization question. So again, I always suggest that we miss out. I'm just going to go left a bit further. Maybe not. Yeah, I always suggest we miss out the first bit and then go straight on to the optimization. So that's a differentiation question. And our very last question, question 10, proving some trig. And then again, this looks like we're going to either be differentiating or integrating. And if you look at the question, it's very much an integration because it's telling you you're going to, you know, this is your dy by dx. We've got to integrate that. We'll end up with our function plus c, and we use these points to solve for c. So, you know, just have a wee flick through your paper, you know, get comfortable with what's coming up. And actually, we you know, haven't gone through that. Quite a lot of differentiation, actually. And that's why I always say that, you know, with differentiation and integration, there's lots of different ways they can dress up the questions. Whereas things like wave function and further calculus, yeah, I know further calculus is also differentiation and integration, but it's a very straight, you know, it's very similar each time, isn't it? You know, for example, that is the same kind of function that they always ask you to integrate. Whereas here, you know, a little bit of a twist there with that general integration, you know, with the differential function. So, you know, just just always worth going through the topics. So have a wee battle plan, you know, what topics do you like? What do you not like? What's going to be in the bag? No logs in this, so hopefully paper 2's got some logs. But yeah, I think like wave function for the calculus logs are always quite straightforward. But anyway, just that's enough of my chit chat. So tangent to the curve, right? So the minute I see tangent to a curve, the minute I see, you know, equation of a line, I'm thinking P, G, E, just the same as any straight line, okay? Now I know that x is equal to 3, so that's fantastic. I've got x is 3. Now how can I possibly figure out, oh, I wrote that. How can I figure out what y is? Well, all I need to do is substitute it into the original function. So if I say y is equal to 2, 3 cubed squared plus 14. So what have we got? 3 cubed is 27 times by 2 would be 54. Take away 8 nines, so that'll be 72 plus the 14. So I'll add those two, so 60, that'll be 68. Take away 72, oops. So that'll give me negative 4. So I'm thinking, right, I've got a point now. I've got 3, negative 4, brilliant. What else do I need to get? Well, I'm going to need to get a gradient. So how do I get the gradient? Well, the gradient will come from the differential. So if I've got my equation, 2x cubed, if I differentiate that, that tells me the rate of change or the gradient at any point along the line. And remember, to differentiate, we multiply and take one away. Like I say, on the side, just come up with something that you remember. You know, maybe that's in your head. You know, like what did I get to do that? Okay, something like that. Just to remind you, so you're multiplying and then taking away one. So how do I work out what the gradient is? I'll have to solve in for my x value, don't I? So I'm going to substitute in my value of x, which is 3. Put 3 in there. Oh, don't know where that's come up. So 6 times 9, 54. Take away, what's that, 48. So the gradient is going to be 6. So right away you're on your way to working out the equation. You've got your point, you've got your gradient. So now it's just substitute in, and I'm going to just put A and B in here. So I'll do y minus b. Go. So that's plus 4. Gradient is 6. Oh no, whoops. Is the gradient 6? Oh, I've just run ahead there. Oh, classic me. Ran ahead of that. That's the gradient of the, let me just put that in there. That's the gradient of the, oh no, that's fine, that's fine. So I thought I was going to have to do a 1 over there. Sorry, it's not. That is the gradient, that's okay, that's okay. I suddenly thought, wait a minute, am I going to do a tangent? You know what it is? I've been thinking a lot about the circle, where you do the line, and then you get the perpendicular gradient for the tangent. But we're not doing that. Our tangent here, is maybe doing something like this, and the point we've got here, dy by dx, is actually the gradient at that point, So we don't have to worry about doing 1 over. There you go, probably brain wobble there. And I'll take away 4 again, so 6x take away 22. And you could write that in any form you like. It doesn't say to write in a certain form. I quite like it in the nx plus c form, because I know then that this is going to be my intercept point. So yeah, question 1 done. Hope that's helpful.